So what's the point? Like, why would we use things like this? And like I did before, I'm going to set up a little table to make this easier to talk about. So I'm going to write the word term, and this is meaning the first term, the second term, the third, and the fourth term. And just that simple 3, 6, 9, 12. Let's see why we could always get a later term as long as we knew the first term and the common difference. So I'm going to say my later term is just way down the road, like a sub 4. Now I know that's not way down the road. I'm trying to find the fourth term. Well, if I knew my starting term of 3, then really I would have to take an additional 3 steps to get to that term. And if I'm taking an additional 3 steps, and each of those 3 steps is the same as a value of 3, because here's 3, 3, 3, so there's my 3 times 3, then I can see that 3 times 3 would be 9, and I'd get 12. So that there's fewer 3's, let me do this with different values. So now instead I have a fifth term of a sub 5, and my starting term of 3 would have to make 1, 2, 3, 4 steps where each step is the same as times 3 to get to 15. So here's 3 plus 12 does give me 15. But what I want to show you is that if you're finding the fifth term, then that means you have to make 4 steps. If you're finding the fourth term, you have to make 3 steps. If you're finding the third term, you have to make 2 steps. So you always have to make 1 step less than your last term. And the only reason I had this 3 here is because it was my first term. And the only reason I had this 3 over here was because it was the common difference of those values. And as long as I plug these in, this will work no matter what term I'm looking for. So as we're looking at the equation here, this a sub n, this is your nth term, and I do want you writing this so I can find the 1000th term if I want. A sub 1 is the starting term, n is the actual number of that term, meaning like the 5th, the 6th, the 7th, the 8th, not the value. And we won't even bother labeling that, so erase it if you did. And then d is going to be the common difference. The arithmetic sequence 12, 23, 34, 45 represents the total number of ounces that a box weighs. So now we're told we're going to have to write a equation for this. So you can look back if you need to, but a sub n equals a sub 1 plus n minus 1 times d. When I look at this arithmetic sequence, over to the right side, I'm going to write what I think d is, the common difference. And going from 12 to 23 is 11. 23 to 34 is also 11, so that's a positive value of 11. Now, The initial term, a sub 1, I'll also do over to the side, because this is going to help me map my work out neatly. So the first a sub 1 is 12. And as long as I have this, believe it or not, we're done. So we need to write an equation for the nth term of the sequence, meaning this is the general case that will work for anything. So for this, I will write a sub n equals 12 plus n minus 1 times d, which is 11. Now we could leave it in this form if we want, but we'll simplify, and I'll write 12 plus 11n minus 11. I'll bring the value at the variable in front, 11n, plus 1, once I do 12 minus 11. So there, we've come up again with a general catch-all equation for the nth term of the sequence. And now that it tells us to find the 10th term in the sequence, now we're just going to plug it in. And as we plug it in, we want to be specific. So we'll write a sub 10 equals 11 times 10 plus 1. So if we did all that work simplifying, then we're going to want to use that. So then I get 110 plus 1, and I get 111. Now these are new problems, and although this one was a little bit more straightforward than sometimes it can be, it's not a bad idea to use reason and logic and test it against the real problem. And here's what I mean by that. So we start with 12, which means I have a book laying there. And if I add 9 more books, well, each one looks like it's 11, so that's 99 more getting tacked on to 12, which is 111. So I'm just using the real problem to kind of check it rather than just redoing my work. Okay, consider the arithmetic sequence 3, negative 10, negative 23, negative 36. And if I look at this, it might be easier to find the common difference from there, because its d is going to be 13, but we're going to make sure it's negative. And then when I check it from going to 3 to negative 10, okay, that's right, it is negative 13. The other thing we can pull right from this is a sub 1, which is the beginning value of 3. And as I jump to writing an equation for the nth term of the sequence, every time I rewrite a sub n equals a sub 1 plus n minus 1 times d, I'm kind of giving myself a little bit more of a repetition of hopefully locking that into memory. Since we're still coming up with the generic case, I'm not going to put the 15 in that I see in the second part, but I will write a sub n. And I will write a sub 1 as 3 plus n minus 1 times negative 13. Now we're going to distribute. I'm going to write that as 13n plus 13. If you're not sure where that came from, just show an extra step and pause the video. Which means I will have negative 13n plus 16. And if that seems strange because we have a negative now, well, look at the trend. These values are becoming more and more negative. The other thing, too, is, you could plug 3 in and do like 13 times 3 is 39, make it negative, and then do negative 39 plus 16, and you would get that third term to check it out. In part 2, they ask us to plug it in. So a sub 15, make sure you're not cutting corners here. It's important that you guys show these steps for arithmetic sequences, because if you don't do it now, it's going to be really difficult to do for future problems of geometric sequences and more complicated situations. So a sub 15 equals negative 13 times n, which would be 15, plus 16. Get a calculator out, and we will write negative 195 plus 16, which gives us 200. No, it doesn't. which gives us negative 179. And unlike the word problem that we were able to deal with in the last one, we're just dealing with numbers and values here. So you could check it either way. Or you could just get a calculator out and add and subtract 13 from 3 15 times, 14 times actually. And it says graph the first 5 terms. Before you redraw what I just drew, look at these terms. 3, negative 10, negative 23. These are 4 terms, which means the 5th term is going to be negative 49. So when we're budgeting our graph, this thing needs to go low enough to where we would have negative 50. So maybe we put positive 50 here, negative 50 down there. The 5 terms that we're being asked to provide, 1, 2, 3, 4. Then the initial term is going to be 1 over, but up 3. Now that should be just a smidgen above the line. Then we're 2 over, and then we're at negative 10, negative 23, negative 39, and these would really just be discrete values, so we leave them as dots. There you go. Hopefully that felt alright. You're going to have a little assignment to go with this, lots of problems, so I'll chunk it over a couple of days or whatever, and we'll see how that goes.